Hello everyone, welcome back to my machine learning sessions. In today's session, we will be continuing with the classification and today we will be learning about the classification metrics. Okay, so before getting into the details, let's see. We already discussed that classification is one of the most widely used problems in many of the machine learning industrial applications like a face recognition, YouTube video categorization, content modernization, medical diagnosis. In the medical diagnosis, yesterday we have discussed about detecting whether a tumor is a cancer tumor or not. Okay, so like that, many medical diagnosis applications are there. Similarly, text classification. Okay, handwriting. Related to handwriting, there are many problems and text classification problems are there, and then speech detection is there. Okay, so based on the social media tweets and all, okay, so how can you classify the data? So there are many applications related to this. Okay, all this comes under the classification problem. And dealing with this, we have many models coming from machine learning models to deep learning models. Coming under the machine learning models, we have the support vector machine, the logistic regression, decision trees, random forest. And in the same way, if you see the XGBoost, which comes under deep learning, convolution neural network, CNN, RNN, all these are classification networks only. Now in deep learning, again, we are making use of deep decision trees and deep random forest also. Okay, so for all these classification models, these metrics are applicable. So how do you measure the performance of a model is with the help of a metric. Okay, so let's see few metrics like that. So today the first metric that we are going to discuss is the confusion matrix. Okay, so it is one of the most basic one. Okay, so this confusion matrix we can also call as ACA error matrix. And here we'll be having a tabular format of visualization of the model. Okay, so where we will be plotting between the prediction and the ground truth, which is the actual one. So what is the actual output and what is the predicted one? So between these two, we will be plotting a tabular form of result. So that we call as a confusion matrix. Okay, so as I told you, since it is a table contains rows and columns. So here in this confusion matrix row, what we will be giving is the actual class label. Okay, so which we call as the true label, and column represent instances of the predicted classes, which we also call as the dummy label. Okay, so this true label we can also call as the ground truth label. Let's see one example. So let us assume that we are building a binary classification to classify cat images from non-cat images. And let's also assume that our test set has 1100 images. Okay, so in these 1100, 1000 are non-cat images, only 100 belongs to the cat images. Now let us see how to plot a confusion matrix for this. Okay, as I told you, a confusion matrix will be a tabular format. So this result is taken from a source. Okay, so already it is experimented. Okay, so you can see the actual class and you can see the predicted class. As I told you, the rows gives us the actual class and columns gives us the predicted class. So now here you can see actually there are 100 cat images and 1000 non-cat images. Now, if you sum up these columns, you will get 100 here, 90 plus 10, you are getting a total of 100. So these are the cat images. And similarly, if you see 60 plus 940, so they are 1000, so which are non-cat images. So here we have 100 cat images and 1000 non-cat images, which are the summations of these two. Done. So now, so what is the actual predicted value? So actually there are 100 out of 100. If you see the true label, okay. So this first one we call as the true positive and this is true negative. So from the previous problem, here we can see that out of 100, 90 were predicted correctly. So what does this confusion matrix tell us? Okay, what is the importance of this confusion matrix is out of 100, 90 were predicted correctly. It is true positive. Actually, they are cats and it is predicted correctly. And 10 were predicted wrongly. Similarly, here coming to the true negative, they are non-cat images. Okay, so this is the data that is already given to us. Okay, so this is true negative. Really, they are non-cats. And out of 1,000, 940 were predicted correctly as non-cats and 60 were predicted as cats. Okay, so this is true positive and this is called false positive, and this is true negative and this is called as false negative. Okay, so this is how we represent a confusion matrix. So let's see once again. Out of 100 cat images, the model has predicted 90 of them correctly and misclassified 10. Okay, so here you can see the cat class as the positive class and non-cat class is the negative class. And then 90 samples are predicted as cat are true positive, as I told you, true positive, and 10 samples were predicted as non-cat are false negative. Okay. So though this is very familiar, this is most confusing part of also for many of the people. So only I'm repeating it again. Similarly, out of the 1,000 non-cat images, the model has classified 940 of them correctly and misclassified only the 60. So this 940 correctly classified samples we call as true negative. Okay, so they are non-cats. That means negative part of it, and truly they were classified as non-cat only. So this we call as true negative, and only 60 were misclassified. So this we call as false positive. And one more thing that you can see is the diagonal elements. So these diagonal elements denote the correct prediction and the non-diagonal elements will give you the misclassification. So the total number of misclassifications by this model are 60 plus 10, 70. So it is a better one only. So now, just to give you a clear understanding, as of now, we have not implemented any model. We have not taken any data set. So simply, let's see how to plot a confusion matrix, how to work with a confusion matrix. So for that, I am assuming the y-actual as 0, 0, 0, 6 zeros followed by 10 ones. The size of the array I'm taking as 10. Okay. Similarly, the predicted ones, if you see, the first we have 6 zeros here. Out of that, 4 were predicted correctly, but the other 2 were predicted as ones. Then here we have 4 ones. Only 3 were predicted as ones correctly, and 1 was misclassified. Okay. And if you see the confusion matrix for this is what we got. Okay. So what does this confusion matrix talk us? Okay. So if you see, just try to recollect. Okay. What is this 4 stands for? This is true positive. This is true negative. This is false positive. And this is false negative. Okay. So now if you see the sum of ones. Okay. So the sum of ones are given by the first row, 4 plus 2, which is 6. And so the total number, if you sum up all these elements, 4 plus 2 is 6, 6 plus 1, 7, 7 plus 3 is 10. So the sum of whole matrix, the total number of samples gives us the sum of all these elements. So which is 10. And number of samples labeled 0 in the original is 6, 4 plus 2, which is 6. And labeled 1 is 1 plus 3. So first row for zeros and second row is for ones. So number of ones labeled as ones are 1 plus 3, which are 4. Similarly, if you see the number of ones in the predicted data sets, okay, 4 plus 1, 5 ones were predicted. Okay, altogether 5 ones were predicted. So that is this true positive plus false negative value, sum of the columns. And similarly, correct classifications, if you see, those are the diagonal elements, which are 4 plus 3. And misclassifications, if you see, they are the non-diagonal elements, 2 plus 3. Okay. So let's see how to perform a hands-on for this. Let's switch back to the hands-on. I'm using Google Colab. You can use. Here I have pre-coded for you to save your video time. So here you can see from sklearn, okay, from this library, we are importing the matrix class, and from that I'm importing the confusion matrix. Okay. So this is the beauty of Colab. So if you click on a particular thing, you will get the related data of this, or else you can go to sklearn.matrix also. Okay. So there you can see all these methods. Okay. So as I have told you, y actual is 6 zeros followed by 4 ones. Y predicted is 4 zeros followed by 6 ones I have given, but in the actual one it is given as 0. Let me match with the original. And now we are plotting a confusion matrix between y actual and y prediction. For this confusion matrix, we are passing two parameters, which are y actual and y prediction. Let's run this cell. Okay. So here you can see 4213. So if you sum up all this, the total is 10, which is the size of the data set or the number of samples. Okay. So the number of correct classifications are 4 plus 3, which are 7. Okay. How it is 7? Out of the 6 zeros, 4 were classified correctly. These are 4. And then out of 4 ones, 3 ones were classified correctly and 1 0 is misclassified. So 4 plus 3 altogether 7 were classified correctly and 3 were misclassified. Here 1 0 and here 2 ones. Instead of this 0, it was classified as 1. Instead of this 6th 0, it was classified as 1. So 2 misclassification, 2 plus the last one. So totally 3 misclassifications. Okay, so this is how you will get a confusion matrix. Now let us see how to plot this confusion matrix using matplotlib. And here I'm also drawing a heat map, not only the matplotlib, the scatter plot and all we have practiced enough. So let's see how to draw a heat map. So here again, the library that we will be using is matplotlib.pyplot only. Okay, so this I am aliasing as PLT. So now plt.matshow. Okay, so I want the confusion matrix result in the form of a mat. And at the same time, I want a color bar also. Okay, so to decode what is the values of in the mat show. And you are familiar with this plt.title. The title of this I'm giving as confusion matrix. The X label is given as predicted and the Y label is the actual one. And here is our result. Okay, let me unzoom it. Yeah, to make the code clear visible to you, I have zoomed it a lot. Yeah. So here you can see the confusion mat. The title is confusion matrix. It is plotted between actual and predicted. So this is the mat show what we have given here. So this one plt.mat show. So here you are getting a mat format, and here this color bar will tell you what are the numbers. What does this colors represent us? Okay. So here if you see this dark purple, it is giving us 0. And here you can see it is 1. And this blue, if you see, it is 2. 1 plus 2, which is 3. And this yellow. So going back to this yellow is giving us, okay, I think I have not run this again. 1 second. It was done for the previous one. Since we have changed it, let me do it again. Yeah. Okay. So now these colors will tell us correctly. Okay. So this yellow is 4 and this blue is for 3. This blue you can see it is 3. 4 plus 3 is 7. The dark purple is 1. And this blue is 2. So from this color bar I'm talking. Okay. 1 plus 2, which is 3. So this is how we can work with the confusion matrix. Hope you enjoyed. If you like the content, please do like, share and subscribe. Next, we will be talking about the next metric.